Good evening, everybody. Hello and welcome. My name is Stephen Hummel. I'm going to be one of your hosts tonight for this Perseid Meteor Shower live stream coming here to you from McDonald Observatory in far west Texas. I'm joined here by Saul Rivera and Dr. Anita Cochran. We'll come back to them in a minute. Um, our hope for you tonight is to see some meteors, and we do have some high-tech gizmos that we hope will show you those meteors, despite, frankly, some less than optimal conditions. Here is a live camera of the entire sky. This is a live camera view, and unfortunately, you really don't see very much at all in that view. That is because, well, it's a little cloudy out. But we do hope to have some clearing in the clouds here shortly. And so we're not going to give up yet. We do have some activities planned just in case it takes a while for it to clear off if it does. But I am coming to you again from McDonald Observatory. Saul and I are here at the Visitor Center, actually, technically behind the Visitor Center in, uh, again, the mountains of far west Texas. That's the Franklin Bass Visitor Center you see on the bottom. We are in our telescope park where you can see some domes scattered around. We're not using those telescopes tonight because telescopes, frankly, are not very good for observing meteors. They magnify far too much. The meteors are just way too big and brief. And honestly, the best way to view a meteor is with your naked eye. But of course, we have to use cameras. So we're just set up outside in that area there. I want to also point out that in our chat, our live chat that we have for you tonight, there are a team of moderators standing by to help answer some of your questions. They will answer questions as we go along, but if you have a question that perhaps is too long to answer in that format, or we think is particularly interesting, those moderators will forward those questions to us so that we can answer them on air here. Also, I want to go over a little bit about the setup I am using tonight, which I will be using to show some views of the area. Saul and I both have cameras. My camera is a little odd. This is a live view from right next to where I'm sitting uh, of the sky, and this is through a night vision monocular, kind of like what the military uses. They're pretty hard to get. They're not cheap, but we've got one here with a webcam attached to it. And so what you're seeing here, this circular field of view is roughly equivalent to the human eye's field of view in terms of just its detailed part of its vision, ignoring your peripheral vision. So not a lot of magnification. What you're seeing here is basically just clouds. Unfortunately, it is cloudy pretty much everywhere we look right now. But you can also see kind of in the bottom there, you can see some of the domes here at McDonald Observatory, just there on the bottom of the frame. But I'm going to turn it over to Saul to introduce himself and talk a little bit about his setup before I hand it to Anita. So, Saul, if you would like to introduce yourself.
Yeah. Hello, my name is Saul Rivera. You've seen me from some of the past live streams already. I work here at the Visitor Center. I do some of the programs. So you can see I have a similar setup to Steven. I have a little night vision camera so y'all can see me better, even though it's completely pitch black all around me. And sadly, my live view is not as good as Steven's. So this is what my camera can see right now. Right now, it's a monochrome camera that gives you a nice view of the entire night sky. Usually, you'd be seeing a lot of stuff going on, but with all the clouds, you just see, well, darkness and clouds.
Yeah, unfortunately, yes, complete cloud cover at the moment. Again, if it does clear up, which it still might, we're going to be here to try to catch those any holes in the clouds. We were going to do this stream for another hour or so, but now I'm going to turn it over to Dr. Anita Cochran to talk a little bit about meteors, specifically the Perseid meteor shower, and basically where meteor showers come from and how they relate to comets. But Dr. Anita Cochran specializes in meteors. I'm sorry, comets rather, not just meteors. And she is an astronomer with the University of Texas at Austin's astronomy department, which is basically synonymous with McDonald Observatory. But hello, Anita. Thank you for joining us tonight.
Hi, Stephen. Hi, Saul. Hi, everybody out there.
All right. So
I'll actually make one small correction, Stephen. I am actually with the McDonald Observatory. I'm the assistant director of the observatory. I'm not part of the department technically.
You're the one exception. You're right. Most of the astronomers, many of the astronomers are with the department. You're with the observatory. I gotta get that straight. All right.
Okay, so I'm going to tell you today, and hopefully by the time I get done with this, it will have cleared up. But you see in the upper right corner of all the slides is the sky live view. So if something happens, you can see that. But I'm going to tell you a bit about the origins of meteor showers so that you have some context of what's going on. And the picture in the background here includes a comet, and that comet's very special because that's the comet that is the origin of this meteor shower. And I'll tell you a bit more about it a little bit later. Next, please. So a meteor, which is often called a shooting star, occurs when dust, rocks, or boulders pass through the Earth's atmosphere. So what do I mean by dust? It's a term astronomers use, but doesn't mean anything. It's not the dust bunnies under your bed. It's really just silicaceous stuff, the rock and dirt that you would pick up outside. So anything from single grains to small pebbles to all the way through to boulders pass through the Earth's atmosphere. And as they pass through, the friction of them passing through, because they're coming through very, very quickly, means that material burns up as it passes through. And so when it burns up, we see a streak as it passes through. And the longer the streak is generally because they penetrated further into the atmosphere. And only the biggest objects actually survive to reach the ground. Most of these, what you'll see in the way of meteors, never come near the ground. When they do hit the ground, they're called meteorites. And if you recover them, they're quite useful to science, but they're also kind of neat to be able to hold something from outer space. It's just not always easy to identify what's a meteorite and what's just a normal rock on the ground. And if you go out on any particular night, when it's dark, you can see a meteor if you're looking, if you're paying attention, but there aren't a lot of them in the course of the night. When you have a meteor shower, things change because that's when lots and lots of meteors occur during some period of time. So it's a night or a few nights, and at that point you can see this continual stream of meteors in the sky. So next slide, please. So where does this dust come from that's passing through the Earth's atmosphere? Well, it generally comes from one of two sources. One of them would be asteroids, rocky bodies, which are generally found in the orbits between Mars and Jupiter. And these things orbit in the same direction as the Earth around the Sun. The Sun does not go around the Earth. The other option is comets. Now, comets are dirty snowballs. They're ice plus rock bodies, and they can be found anywhere in the solar system. And they're the leftovers from when the giant planets formed. And the difference between a comet and an asteroid, as far as orbits are concerned, is a comet can orbit in any direction around the sun. It can be going the same direction as the Earth. It can be going opposite from the direction of the Earth, which is what Comet Halley does. It can be coming perpendicular to the orbit of the Earth around the sun. And that's what Comet Hale-Bopp in 1997 did. Next, please. So which causes the meteor streams? Well, you can get meteor streams from asteroids. There are one or two cases, but most meteor streams are caused by comets. And comets are really pretty small. They're 1 to 30 kilometer or 0.6 to 25 miles across bodies. They're about 50-50 ice and dust by mass. And the ice is stuff like water. About 80% of it is water. Then it's carbon dioxide, carbon monoxide, ammonia, methane, formaldehyde, all sorts of things. And the dust is small grains of rocks and pebbles up to boulders, and it's silicaceous material generally. As the comet approaches the sun, it's heated, and so the ice turns to gas. Now, if you took an ice cube and you sat it down on the table and waited as it warmed up, it would turn into liquid. So why does it turn to gas? Well, in space, we have almost no pressure up there. So, I mean, it's better. It's a really good vacuum. So the stage of going to liquid is not an allowed stage in the chemistry. So it goes directly from the ice to the gas, and that's called sublimation. And as the gas flows out, because the object is very, very small, it doesn't have very much gravity, as the gas flows out, it drags some of the dust with it. Now, the dust doesn't stay attached to the gas for very long. By about 50 to 1,000 kilometers, or 300 to 600 miles from the nucleus, the gas and dust start to separate. And some of the gas will actually become ionized. Some of it stays neutral, but some becomes ionized. And the dust is also flowing out. And the ionized gas and the dust can form tails, and they're two different tails. So if you go to the next slide, please. This is a picture of Hale-Bopp, and is a great picture for demonstrating this. The nucleus of Hale-Bopp, which was about 30 kilometers across, one of the biggest of the comets, is way, way down in the tip of that, in the lower right of the image, and you can't see it because there's all this gas and dust in the way, and that's called the coma. And then you see two tails coming off. One is blue and one is white. And if I got this picture without the labels on it, because the sky does not come labeled, I could tell you right away that the blue is the ion tail, so that's the gas, and the white is the dust tail. And that's just the way it is, because the blue comes about because there's oxygen and carbon monoxide in the spectral region that makes it blue. Now, if you look at this picture carefully, you'll see that the blue tail comes off very, very straight, and it's all going off to the upper left. And if I went down that tail from the upper left through the nucleus and kept going, that's the direction of the sun. I know exactly where the sun is in this picture because it's pointing to the sun. On the other hand, the dust tail has a sort of curve to it, because when the dust disentrains from the gas, it continues to follow an orbit, but it's in a circular orbit, or not a circular orbit, it's in a curved orbit around the sun still. So it stays in orbit around the sun and just follows behind the nucleus. But because it doesn't have some of the jet forces of the nucleus, and because it's tiny stuff and it's being pushed by the solar pressure, it's trailing behind. Next slide, please. So once it's separated from the gas, the dust in the tail acts like separate little bodies. So there's thousands and thousands of little tiny bodies following along behind the comet. And they continue in orbit around the sun. And when the comet comes back for another time, it reinforces the tail. Might be wider because it might not hit exactly the same place. But also radiation pressure from the sun and a form of drag called Poynting-Roberts drag causes the particles to spread out along the cometary orbit. But they don't disappear completely. As a matter of fact, they can remain through several orbits. They can remain for 1,000 years. So they can remain in orbit around the sun. And when that orbit of those dust particles intersects with the orbit of the Earth around the sun, then the particles can enter the Earth's atmosphere and we get a meteor shower. So it's very simple physics, but it's sort of complicated picture. Next, please. So the Perseid meteor stream is the one that exists in August. It's always a good, reliable stream and fun to watch. I've actually observed it since I was a little kid. It's the result of the intersection of the dust tail of Comet 109P Swift-Tuttle. Well, Comet 109P Swift-Tuttle was discovered in 1862 by two independent observers, Lewis Swift and Henry Parnell Tuttle. And that. Let me explain a bit about how comets are named. When a comet is discovered and is verified by the International Astronomical Union, the first three independent discoverers get to, before the announcement, get to have that named after you. If the 5 people are discovered all at the same time, it's the first 3. If one person discovers it and gets announced and other people discover it later all on their own because they weren't paying attention, it's just the one at that point. So most of them are named after people. There are a few exceptions to this. Some of the big surveys that are being done these days name it instead of after one of the members of the survey. for just the survey itself, such as Pan-STARRS or Atlas. These are surveys in Hawaii and Arizona, respectively. And a couple of comets in the early days, like Comet Halley. Halley was named for the person who figured out that this comet comes back time and time again. Well, Comet Swift-Tuttle does come back time and time again. The fact that it's 109P says that it's periodic, so it will come back time and time again. And the most recent return near the sun was in 1992. Although we've traced it back in the Chinese records to 322 BC. So we've only known about it in the sense of following it carefully since 1862, but we can tell that it was observed all the way back to 322. Next, please. So the picture on the lower right is this one that was on my title slide, and that is indeed a picture of Swift-Tuttle. It was taken in 1992, the last close approach, by somebody who was in Slovakia. And this comet comes back around the sun. I told you it comes back periodically. It comes back every 133 years. But it doesn't go around the sun in the same direction that the Earth does. In fact, it goes around somewhat in the reverse to the Earth's orbit, but with its orbit tilted to the plane that the planets go around, and it has a very elongated orbit. Next slide, please. So I'll explain that all on the next slide. So this is an orbit diagram, and what you see in the colorful, in everything but the magenta, is the planets going around the sun, and the green is Jupiter, the red is Saturn, and the yellow is Uranus. Obviously Neptune's out past there. That just wasn't relevant to this. And inside you see the Earth and all the other planets, but they're so tight in you can't see them. You'll notice that the three planets that you can easily see, Jupiter, Saturn, and Uranus, are all going in the same direction around the sun. Now the purple orbit is the orbit of Swift-Tuttle. You can see it's very, very elongated. The others are more or less circles. And it's going the opposite direction around the sun. So if it were going the same direction, it would be turned around and going reverse of what it's doing now, but it's going the opposite direction. So that means when it's coming in and then making an approach, it's coming in pretty fast. You also notice, if you watch this for any length of time, that it goes much faster when it's near the sun than when it's far from the sun. That's Kepler's laws that say you sweep out equal area of the orbit in the equal amount of time, and so it goes faster when it's very close to the focus, which is the sun. The vertical lines are trying to show you that it's not really flat to the same picture as the orbits of the planets, but it's actually coming down at an angle, and the angle it's 131 degrees with respect to the orbit of the Earth around the sun. So it's going backwards, and not quite all the way, which would be 180 degrees, but tilted just a bit. Next, please. So when you go out to look at this meteor stream, why is it called the Perseid Meteor stream? Well, if you look at the sky as there's coming out, there's going to be meteors going in every direction, but they're all going to seem to come from one point, and that's from the constellation Perseids. So if you trace the stream backwards in the sky, they all appear to originate from the same place, and that's called the radiant. But the meteors aren't coming from Perseids, which is way, way far away. They're coming from around 100 kilometers or 60 miles above the Earth's surface. They appear to come because that's the intersection point of the two orbits. So that's your first clue of, if you want to watch them, you want to be looking towards the constellation Perseids. Next slide. So when's the best time to see the shower? Okay, peak shower. This happens to be a fairly wide stream, and therefore this meteor shower can actually be seen over about a 2-week period. But the peak is over 3 days, tonight, the next night, and the night after that. And the best viewing will be after midnight, because that puts Perseids high in the sky. You also want no moon to wash out the view. Well, you're in luck, because it just happens that this year, for the next couple of nights, the moon is setting before midnight. So that really helps you. So if you don't get the window of the clouds or your schedule or whatever, we're seeing clouds right now. Whatever happens, you could see it tomorrow night or the next night, or maybe even the next few nights. But then the moon's going to become a real big issue. So there'll be still more than the normal numbers of meteors in the following few days, but not as many as at the peak. And as I say, the moon will start to interfere. Next slide, please. So do you need special equipment? Nope. Matter of fact, you don't want any equipment. Your eyes are the best equipment you can do because they have a very wide field of view. If you use a binocular or telescope, you're just not going to see them because you're never going to be pointed in the right direction. You want to go somewhere which has few lights, which includes house lights, street lights, moonlight if there were moon, and where you have a wide open view, because if you have trees in the way, you're not going to see something very well. If you're going to stay out there for any length of time, you want to get comfortable. Perhaps a lounge chair so you can, be leaning back and looking at the sky and face towards the constellation Perseids. And then stay and enjoy it for as much time as you can. You might see many dozens of comets. They may come close together in time, or you may see a few and then a gap of 10 or 15 minutes and go, oh, it's over. And then bang, 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 bang. So you'll never know what's going to happen until it happens. But it's really quite impressive to see one of these showers. Next slide.
I do want to point out, you may see many dozens of meteors, not comets.
What did I say? Oh, comets, sorry.
Yeah.
I just love comets. What can I say? So that's my final slide. Enjoy. And hopefully, maybe we'll get some weather. Doesn't look it.
Yeah, unfortunately, at the moment, we still have some pretty significant cloud cover. And those flashes you're seeing periodically in this live view from the night vision are distant lightning. But I don't want to alarm you. We definitely haven't heard any thunder. And what this can pick up is far fainter than what our eyes could actually pick up. So I'm not actually even seeing those flashes. They're so far away that it's invisible to the human eye, and yet this can still pick it up. But again, if you like right there, I see nothing around me. It's remarkable. But if you have any questions for Anita, then please let us know. You can say that in the chat, and we'll forward some of the questions along to Dr. Anita Cochran. And again, she's an expert on comets, so meteors, comets, anything like that, or even just what it's like to be an astronomer and work at an observatory. All great subjects for her. I do want to point out in this live view, on the bottom there's this little bitty dome that you can see right around there. And that is actually the dome housing the 107-inch or 2.7 meter Harlan J. Smith telescope. And Anita, I believe you have some experience with that telescope.
Just a few nights on that telescope, a few hundred nights on that telescope. Yeah, I started looking at comets with that telescope in 1978. And I've seen probably 250 comets in my work on that telescope and a few others.
That's a lot.
Yeah.
You have used that telescope more than most, that's for sure. We have a question here for you, Anita. Quantum Alchemy 369 asks if the ionized tail is not a plasma.
Yes, the ionized tail is a plasma because it is ionized, but it's not a terribly strong plasma because there's just not that much density of gas in it. It is being pushed by the solar wind, which is a much stronger plasma and moving very quickly away from the sun.
There's another question for you from Stephen Yanagasawa, who asks, what can comets tell us about our solar system? That's a great question.
It's a great question. And hi, Steve. What can comets tell us? Well, they are the leftovers from when the solar system formed. And so we know that they're made of ice and dust. And if we look at what that ice and dust is, it can tell us about the conditions in the solar nebula at the time that the sun and the planets formed. And so we study comets because we're trying to understand the early solar system and the history of the early solar system, and because they're the prettiest things in the sky.
Here's another question for you. DL asks Dr. Cochran, do you know when the next best viewing comet is going to be for beginner observers?
Yeah, I wish I could give you an encouraging answer. There are some comets that, from my point of view, are bright, but not from your point of view. We do not know right now of the next really bright one. There was one last summer with Comet Neowise, which was able to be viewed without any telescopes or whatever, but there's none of those on the horizon. The next one I know that's going to be real bright is 12P Pons Brooks, and that's 2024. Maybe it's 2023. I can't remember exactly.
So a ways off. Yeah,
a ways off. That's not going to be all that bright. It's going to be just barely bright enough to see without the aided eye, if it goes to its predictions. And comets, well, as David Levy likes to say, comets are like cats. They have tails and they do whatever they want to do.
A follow-up question. We didn't really know about Comet Neowise too far in advance either, did we?
No, we did not. Nope. Yeah. It was discovered in March. It was pretty faint when it was discovered. It was not. It would have been struggle to see with many telescopes, and then it went into conjunction with the sun. So the sun was blocking our view. It was too close to the sun, and it wasn't until it came out on the other side that it was really bright, and that was in July.
Another question. Book Davies asks, have there been any recovered meteorites from this meteor stream historically?
I don't know for sure. I would guess probably not, because it turns out one of the things that prejudices our collection of meteorites is that things have to be hard to get through the atmosphere. And comets have a tendency to soft and fluffy. So the density of cometary material is very, very low, very high porosity and very fluffy. And so it doesn't tend to make it through. We do collect some dust in the upper atmosphere with U2 planes, believe it or not. But as far as I know, we don't have meteorites from this comet. But I might be mistaken on that one.
That's pretty cool that they've collected it from planes. I didn't know that. That's amazing.
Yeah. But cool. The problem with collecting it from planes is you don't know what comet or asteroid it's attached to when you pick it up in the upper atmosphere. You just know that it's there because it's being distributed.
Another question. Bodster W asks, how many meteor shower events happen per year?
Generally, somewhere around a dozen. Up to, it may be up as high as 20, but some of them are much more notable than others. This is always a good shower. The Leonid shower, which is in November, is really incredible every 33 years, and in between it's sort of a snoozer. Then there are other ones that are fairly populated and interesting, and many that are just not very populated. The Perseids, not the Perseids, the Eta Aquariids are Comet Halley, for instance. And there are various different ones. The Geminids are the one exception where we think it's probably an asteroid that was the parent.
Yeah, will do. All right, so we are getting some raindrops out here now.
Oops.
Not so bad, and my webcam actually is somewhat weatherproof, so we're good for a while, but Sol's going to leave us for a bit and get his setup put away, just in case it starts raining a little harder. But in the meantime, let's get some more questions here.
I saw one go past that said, could you explain to the group the difference between a meteor shower and a meteor storm? I mentioned the Leonids and every 33 years are incredible. That is a meteor storm. There are between 500 and 1,000 meteors an hour in that storm. Showers tend to be a dozen to 100 in the course of an hour. So that's the difference. It's in volume. And the Leonids are incredible if you get to see them. But as I say, it's every 33 years. And don't ask when that is, because I don't remember when I saw them last. I did see them, but I don't remember. I was out there standing on the catwalk of the 82-inch telescope, but I don't remember when it was.
Yeah, I have not seen a meteor storm like that, but I have seen the Leonids before, and even on an off year when they're not storming per se, they do. They're still quite a show. Not quite as
They're quite a show because they're very long-lived. They tend to be a little harder than some of the others, and so go through much longer. So you can have somebody go, "Whoa, look at that!" and everybody can turn and look and still see it, which is quite impressive.
Another good question I saw for you, Anita, is about how long is a typical comet tail from Josie Creative?
Well, some of the comets don't even have tails, so they go from nothing. They just don't put out enough material to, for instance, a comet like Comet Neowise. The tail was probably about 500,000 or 600,000 kilometers long. It's pretty big.
Wow. I mean, yeah,
comets are actually the biggest things in the solar system, but they're so low density that you don't notice it.
All right. Sorry if there's any wind noise, but Paul Hernandez asks if comet or meteorite, or I guess meteor, I believe is what he means, would make any sound or any noise with the right equipment.
I believe they do, especially if they come in and they can cause sonic booms if they're big enough. I believe they do, that there have been listening stations for them, but I don't know much detail on that.
Yeah, I can say during a particularly enormous meteor, really what we would call a bolide, which is when they light up the whole sky, and really a rather larger chunk burning up in the atmosphere. I did hear one once that made almost a sort of sizzling bacon sound, like
Okay.
bacon in a frying pan. It was really,
Yeah.
it wasn't loud, but it was still very obvious. So really interesting.
And when you see these meteors coming through, sometimes you see colors, and red or green, and that will tell you not much. It tells you a little bit about the meteor, but it tells you more about what layer of the atmosphere it's going through and what it's burning up around it.
So I've often seen them make a green color. So what exactly is it that's making that green color?
Oxygen.
Oxygen. What about sort of a more yellowish tone?
That would probably be sodium, but I don't know for sure.
Yeah, I've only ever seen yellow or green, but if you think you've seen a meteor of a different color, I'd be curious to know. Here's another question, a little more English-related question, but do the words comet and coma come from the same root word, or why is it called a coma? Rainy.
Yes, I believe they do come from the same word originally, and I'm embarrassed to say I don't actually know what the etymology is of the, where the words come from, so can't answer that one.
Yeah, unfortunately, I don't have a good answer either. But I bet there is an answer out there. We just don't happen to know it offhand. Dana Day asks, well, our telescopes are below the clouds, so we don't see much. Our satellites are way above, so our satellites able to see any meteors burning up. I could take that one if you don't mind.
Sure.
Yeah, so most space telescopes are aimed into deeper space, but there are some equipment aimed back at Earth that could capture meteors. There have definitely been many pictures taken from the crew on the International Space Station of meteors burning up in the atmosphere below them, which I think is really neat. You can look up some of those pictures. So yes, they could see them since they are above the clouds. But just like on Earth, you still have to be looking at the right place and the right time and ultimately get lucky.
Right.
All right, let's see if we get one more question, and then I'm going to hand it to Saul while I tear my equipment down because of the rain. So let's see here.
Somebody, before you ask another question, I see somebody asked, could the meteors hit the satellites in the ISS above us? And the answer is, at that point, they aren't meteors, because a meteor is when it's in the Earth's atmosphere. And those are above the Earth's atmosphere. That would be a meteoroid, and yes, they get hit all the time by little bits of debris.
All right. So I'm going to hand it to you now while I put my equipment away because unfortunately we do have some rain apparently in the area. All right.
Yeah. Okay. Thank you, Steven.
All right. I'll
Yeah.
see you in a bit.
See you in a bit. Let me. There we go.
This is the reality of being an astronomer: is weather gets us every time.
Yep. Good old rain and weather and clouds. Yeah, so something I'm going to cover a bit over is, well, as you can tell, you might hear a bit of an echo. I'm inside one of our domes that's nice and safe in here. And now that we've been talking about meteor showers, let's talk about some big ones. So one of the big historical ones is the Lyrid meteor shower. So these meteors are seen near the constellation of Lyra. They're caused by Comet Thatcher, and they're actually one of the oldest recorded meteor showers. They were first recorded in 687 BCE, and what's called I might be mispronouncing this, the Zhujuan, which was an ancient Chinese narrative history. Basically, they kept track of big events like historical events, political events, but they also kept track of some astronomical ones, like this meteor shower. And in it, the shower is described as stars that fell like rain. As you can see here in my little slide, you can see kind of the area it radiates from. Now, another big one, which Anita mentioned, was the Leonids. So a typical Leonid shower, they occur annually near the constellation of Leo. And they're caused by the comet Tempel-Tuttle. These meteor showers usually produce a couple of dozen or so meters per hour, and they're pretty nice sights. But kind of Anita had mentioned that every 33 years, there's a huge peak in activity where you can get a whole bunch of these. And there was actually an event in the 1800s where it was just, as one of the description was it, magnificent beyond conception. Now picture this. It's 1833, you're just at home sleeping, then someone comes to you, knocks on your door at 3 a.m., and tells you, hey, the sky is falling. And you just go outside and you see this. Just thousands of meteors just falling from the sky. It's recorded that with a typical Leonid meteor shower, you get a couple dozen meteors per hour. But when this occurred, there was tens of thousands per hour. People literally thought the world was ending. Because you just go up and you just see the stars falling from the sky. And all these were depictions of when that occurred from the woodworks. Now, people didn't really know what meteor showers were at the time. They originally thought they were caused by disturbances in our atmosphere, or they were just an atmospheric event. When this occurred, there was already, well, let me rephrase that. When this occurred, you could actually see where these meteors were coming from. Usually, if it's just a couple dozen and you don't know how they behave, they might seem kind of random. But when you have tens of thousands, you can start to get a pretty good idea of where in the sky they radiate from. So an American physicist and astronomer by the name of Denison Olmsted noticed this. He noticed that all the meteors were coming in from the area and started wondering, hey, maybe this isn't caused by the atmosphere. Maybe it might be something else. After that event, he started noticing, as well as other astronomers at the time, that these events occurred every year. The atmosphere doesn't behave well enough to do the same thing every year. So they started thinking maybe it was something that was going on in space. And this actually big event did help us learn more about meteor showers and what caused them. The reason that every 33 years there's a big peak is that's when the comet comes back near us. Well, when we go through that path of the comet, we get our meteors, and every 33 years, when the comet goes back through, we're basically getting a restock. We're getting a new supply of particles that we can go through, giving us a lot cooler meteor showers. And if you're wondering what the next big one is, it's gonna be a bit of a wait. So let's estimate the next big Leonid meteor shower will be in about 2031. So, you got about 10 years or so to plan your event. See, and let's see if there's been any questions that have come through while Steven's still packing on up. Or is there anything you'd like to add, Anita?
No, I think you did a good job on explaining the Leonids.
Oh, thank you. See if there's been any questions that come in. Let's see.
All right, I am back indoors. Nice
Welcome
and dry.
back.
Thank you.
Right now, we're trying to see some questions that have come through. Let's see. Well,
I see one that's interesting, which says, could you melt down a comet in space with a controlled abrasive substance or water? Well, since it's a bunch of ices, all you'd have to do is melt it down by heating it. And that would cause it, if it were in an atmosphere, that would cause it to melt. Otherwise, it would sublime into a gas. And then the dust would just sort of fall out. So, yes, it's easy to get rid of it just by heating it. And that's what happens every time it comes past the sun. Now, each time a comet comes past the sun, it only loses maybe a meter of material. And these things are kilometers across. So the comet we know that's come back the most often is Comet Encke, which comes back every 3.3 years, never gets out even as far as Jupiter's orbit, gets into almost Mercury's orbit. And it's been seen doing this for almost 200 years now, every 3.3 years.
Oh, a question that came in, not sure if y'all answered it when I was transferring over. From a Bernadette Egley. Dr. Cochran, do most meteorites land in basically the same area of our Earth?
No. Well, unless you count as the area is the ocean. Remember, 2/3 of the planet is covered in water, and so the chances are it's going to hit the water. But they don't come into the same area unless it's what they call a strewn field, where something's breaking up as it's getting the last little bits of entering, and then they just sort of scatter right along the path at that point. Now, we collect a large number of them in Antarctica, and the reason is not because more of them hit there, but because you have this ground that's white and these rocks that are dark, and you can go and just pick up anything that's on the surface of the white snow is likely to be a meteor. Or meteorite, correction.
How do I get that job? Wandering through Antarctica looking for meteors. Sounds like an interesting adventure.
I know somebody who's done it. He happens to be the head of the Vatican Observatory right now.
Oh, wow, interesting. Yeah. A lot of people don't realize the Vatican has an observatory.
It does with the telescope in Arizona, actually.
Exactly, yeah. I wanted to talk a little bit about our largest telescope here at McDonald Observatory, the Hobby Eberle telescope. It's an enormous 10-meter or 394-inch diameter telescope. It's like gathering area. And by pure chance, wasn't designed to do this, but it turned into quite a meteor detecting machine, didn't it? Maybe Anita, you can comment a little more on that. But what makes the Hobby Eberle telescope so great for detecting meteors compared to others?
Well, it's not the telescope itself. It's the Hobby Eberle Telescope Dark Energy Survey that's going on. And that's because it's looking at a very large, for a big telescope, a very large field of view, and looking at it a lot. And so things just go through the field of view, and they're very sensitive. This instrument is very sensitive, and it gets spectra of them as it goes through regularly.
And that's not easy to do. Getting a spectrum of anything, frankly, isn't easy to do.
Right.
Because you're taking the light from an object and breaking it apart into its component colors. And doing that by spreading the light out so you can then further analyze it. You lose a lot of the light, and a lot of it gets smeared out, so it's fainter. It's like if you have a deck of cards, 50 cards, and you smear them all out, it's going to be a lot thinner. Likewise, if you have a bunch of photons, it's really bright, smear them all out, it's going to be fainter. So getting spectra of something that's really brief and small in general is hard. So you kind of have to have a large telescope to get it. And there's not really many other telescopes that routinely do get spectra of meteors, except for the Hobby Eberly telescope.
Yeah, there are special programs that do, and they're doing it with very different kinds of equipment, but they tend to go after the meteor streams.
Again, if you were just joining us, we are unfortunately rained out of the sky tonight. It is completely cloudy, and it is now drizzling a little bit. So we have put all of our sensitive equipment inside. So again, if you're just joining us, we're basically just taking any questions you may have. Dr. Anita Cochran is an expert on comets and just in general astronomy. So if you have anything to ask, now is the time to do it. Again, thank you all again for joining us and understanding. I did see a question that was worth answering about how long can we see the Perseid meteor shower? How long does this last?
Its peak is about 3 days, but you'll probably be able to see it for about a week. I mean, you'll see an increased over the background for about a week after the peak.
So there's still time.
Yeah, it's a fairly wide stream. Not all of them are as wide. But the moon's going to be becoming a bigger and bigger problem.
Yes, exactly. The moon will start to get in the way. Pesky moon. Here's a question. Would an astronaut avoid a spacewalk at this time due to the dangers from possibly being hot? It's amazing that we can see the effect of such a tiny but fast particles entering the atmosphere miles away. So, yeah, it's an interesting question.
Actually, the spacecraft would have to be in the path of the comet, in the orbit of the comet, near the Earth to have any effect from the meteor shower. Because if they're off the orbit, they're not in the stream. So, yeah, they would see something if they were really in an unfortunate position. And I don't know whether they even take that into account.
Yeah, I mean, what you mean by in the stream, are you saying that you're on the side of the Earth that's sort of facing along with the Earth's travel? In other words, the morning side of the Earth, roughly?
Right.
Yeah.
Yeah, and where it intersects in Perseus, basically.
Mm-hmm. So, in other words, you got to be in the line of fire, and then maybe
you wouldn't want to be out there, but
yeah.
So another question that came in from Josie Creative. Question for Anita from my son Nick. Hi, Nick. How long is the typical comet tail?
I believe we did address that one, but yeah, you go ahead. Yeah, go ahead.
Yeah, there is no typical, unfortunately. There are comets without tails, Manx comets, and there are comets that have very, very long tails, and there can be, 500,000 miles.
Oh, wow.
Or more.
I think
500 million miles. Sorry, misspoke.
I have a question for both of you, Saul and Anita. What is the best or most memorable meteor you've seen?
Oh, I think the time I saw the Leonids from the catwalk of the 82-inch was probably the most memorable.
Yeah, superstorm of tons of Saul, do you have a favorite?
To be honest, I've never had good luck. I was hoping this would be the year I actually get to catch a cool meteor or meteor shower, but
that's what's wrong with it tonight.
Yep, I've never had good luck. I've seen some cool singular ones. I think but usually, again, sometimes I would miss them. Actually, at one point, there was a time I was presenting stuff up. There was a meteor shower going on, and when I was looking at it, I wouldn't see anything. The moment I turned my back, I would just hear, ooh, ah. Turn back, it's gone. And rinse and repeat.
Well, I think we are reaching the end of the program here. So if you have any questions for us, please let us know. This is kind of the last call. But I want to thank you all for hanging with us. I know the weather really just did not cooperate with us tonight. Just frankly, kind of the worst case scenario of lots of clouds, a little bit of drizzle, and threatening more rain. So we appreciate your patience with us. Hopefully, in some future meteor shower, we will do another one of these programs. The most likely one, I don't want to promise this, but most likely one, if not the next Perseid next year, would be the Geminids in the winter. But it is pretty cold, and it's December, so we'll see. But again, we can't just reschedule these programs. Unfortunately, there's too many other things to work around. So that's going to be it for this year for the Perseids. But again, if any last questions for us, let us know. Otherwise, this is going to be the end of the program. So thank you so much. So if you see any, Saul, let me know.
I see one. I think it could be a little thing that each one of us could put in. Could you share from? Sorry if I'm misreading this. Feiruz Shahriar. Could you share some stargazing tips for amateur astronomers? As a first timer, what could I view with the naked eye? So with my kind of tip for amateur astronomers or just to get into it, a really good thing you can do is just to get familiar with the sky, what constellations are where, and even if it's bit by bit, knowing that layout can help a lot. A lot of times if I want to find a target or something through a telescope, it's usually easier for me to be like, okay, it's near this constellation or near this part of the constellation. Once I know what constellation that is, I can actually do a good thing of finding where it is and expand from there.
Yeah, I mean,
sorry, go ahead.
In a dark site, which is always advisable, you can see the Milky Way. This big, a lot of people think it's clouds in the middle of the sky, but it's actually our galaxy that you can see. You can see that. You can see the planets. They get helped by looking at them with the binoculars, but you can see them in the sky. And like right now, there are planets up. There would be if there weren't cloud. And of course, meteor showers are a good thing to see with the naked eye. And just as Saul said, just get used to the sky. I have to confess, as being a professional astronomer, I can't tell my constellations very well. So I have to go by coordinates. I grew up right outside New York City, though, so I didn't have much of a sky.
Exactly. And unfortunately, dark skies are fewer and further between increasingly in the world. So, but making that trip out to a dark sky site like here at the observatory or other places is well worth it. And if you didn't love astronomy before, when you make a trip out and you see the Milky Way above you on a dark, moonless, clear night, you probably will fall in love with astronomy, or at least have some greater appreciation of it. All right. Well, I think that's
gonna... And look up. Always look up.
Look up. Always look up. That's going to wrap up our program. I want to thank my moderators as well for helping us out behind the scene, as well as Frank Ascienzualo, who's helping us out here in person, making things work, keeping us safe. So, again, thank you, everybody. And thank you also to Saul and Anita for joining me.
And thanks all of you guys for joining us tonight. I'm sorry we didn't have better weather.
All right.
Y'all have a good night.
Y'all. Clear skies.